Hi class, so what I want to do today is go through the descriptive statistics worksheet that's on page 13, I believe, in your text, or your worksheets, right? Yep, 13. Okay, so some descriptives that we're going to look at in here are going to be helpful for us to look at data, right? So descriptive certificates, descriptive statistics are statistics that will describe our data set, right? So we're going to use the CAT score sheet in datasets, and I downloaded this as Eric Gay's datasets on Canvas for you, so you can download that and follow along. So here's just saying descriptive statistics, right? So it says note that the name of each function in Excel is given in the spreadsheet, except for the mean, which uses the average function, and the range, which is max minus min, right? So all of the functions in Excel we can use to find descriptives. So it says enter the appropriate functions into the spreadsheet to compute the following and write the formula you would type into Excel after each definition, right? Note there are 98 scores listed in column B and cell range B4 through B101. And it says it has been named scores, right? So let me go double screen here, and I will open up the gaze to well, maybe I didn't download it yet. So I'll go into, so we're going into our course, go into modules. It's under week 1 agenda, and you'll see here Gaze datasets, right? So click on that. I'll just save it to my desktop, and now I have it. So on the bottom, we want to go to the tab that's CAT scores, right, which is the very first one, right? So this is the worksheet that we're working in. Oops, I want the OneNote up. All right. Right. So the mean here, we're told, is the average arithmetic range, right? So if I select the scores, right? So first of all, just to kind of explain what's going on, this term count, this is referring to as counting how many pieces of data we have, right? So count 1 is the first data set, right? Count 6 is the sixth, and so forth, right? So it can make it an easy way to count how much data you have, right? So the data we're actually working with are the scores. So this would be cells B4 through B101, right? As told to us, right? But if I highlight this, one thing you'll notice is here where the cell address is labeled, it says scores. So if I want to name this as scores, I can just type in scores in this box and hit enter, and it's going to name these cells scores. So I can use the term scores instead of having to type in a specific address, right? So you can do this for one cell, or you can do this for a range of cells. And the nice thing about doing this is this creates an absolute cell reference, so we don't have to worry about a relative cell reference if we want that to be fixed, right? So you can use that, or you can type in the actual range, right? So for example, when I go into mean here to type in to calculate the mean, right, which is the arithmetic average, so you can think of mean as like leveling everything out, right? We're equally distributing all the scores so everyone has the same, right, if you will. So I can hit equals and then type average, and then notice the very first one, this is the Excel function I need. I can double click on that, and then I can go ahead and just type in the word scores, right? And you can see that it's labeled here, right? So I can double click on that, and it's going to reference, whoops, let's see what happened here. It's going to reference that those cells, right? So if you don't like doing that, right, in place of doing that, you can just go in and just highlight the cells or type the cell range, right? So I'm just going to highlight, and we want these scores, right? The mean. So either way, we get the same mean, right? So then next, the median, right? The median, if you remember from reading the text, is the middle of the data set, right? So that means you put your data in order from smallest to biggest, and we're going to cut it in half, right? We're going to find the data value that's right in the middle, where 50% of our data are above and 50% of our data are below, right? So to calculate the median, you would just hit equals median, and then we can just type in data. Oops. Oh, excuse me. We saved that as scores. Right? And it'll calculate that. Yeah. So I'm not sure why that's happening in this document. It must be how it was created. Let me try highlighting these scores. I'll try naming it something else, and maybe it'll work out better how I was hoping. Right, so I'm just going to call it data. Right, so let's try that. So here, we'll just call it data. There, that's working, right? I think maybe what was happening before is in this Excel spreadsheet, if you remember right, there's a lot of tabs, and this came from the textbook. My guess is that there's more than one sheet that had named cells, scores. So it's probably being confused, and that's why like multiple are popping up and telling us where they're at, right? So what I did is I highlighted these cells, right, the data that we want to look at, and I typed up here data and hit enter, and that just renamed that range of cells, right? So now you can see how much easier it is to work to be able to name, right? Where before I don't know that it was showing how easy it was. So if I hit equals and then type in median, right? So I want this Excel function, and then I can type in data, right? Because that's what we named those cells, and hit enter. It'll calculate the median, right? So now I can do the mode. So we want this mode here, the one that at the bottom, right? Just MODE, not the other ones. And then we can type in data again, and the mode will be calculated, right? So the mode is the most frequently occurring value, right? So then next on our list of descriptive statistics is the standard deviation, right? If you remember from the reading, the standard deviation is the average distance of the data values from the mean, right? So what we do is we go through each data value, right? So I would go like score 1, 35. How far away from it is from the mean, right? And the mean here is 26.044, right? So you would subtract 35 minus 26.044, right? How far away is it? And do that for all these values, right? And then you average average those, and that's essentially what standard deviation is, right? How far away on average are the data values from the mean, right? It helps you understand how spread out your data is, right? So to calculate standard deviation in Excel, we can just hit equals, and then it's STDEV, and again, we want the one that doesn't have anything extra on it, just STDEV, right? So click that, and then we can type in data, and there's the standard deviation from that. And then now we want to find the max, so we can use the max function, type in data, and we get that, right? And as you could imagine, the max is the largest value, right? So Excel is just looking for what's the biggest value, right? And then for minimum, right, we would hit equals min, and then we want this function, and then you would type in data, and then hit enter, right? And then for range, you're actually going to take the max minus min, right? Max minus min, and hit enter, and that gives us the range. So the range is what's the distance between the max and min, right? And then the count, so we would do equals count, And what the count function does, it just counts how many numbers we have, right? So if we type in data, it'll tell us, oh, we have 98 data pieces, right? Pieces of data. Excuse me. And note here that count, so typically in statistics we use a capital N to denote how many pieces of data we have, right? So that's just general terminology. Right? So then now what Excel is wanting us to do, or this worksheet, is to create a histogram, right? Now creating a histogram in Excel is not too complicated. It's much easier than trying to create a box plot for sure. And we're going to look at box plots in a little bit. So in order to create a histogram in Excel, what we need to do is we need to count how many values are less than specific scores, right? So you can see here these are cutoffs, right? So cutoff, these will be provided to you if you have to create a histogram. You don't have to come up with your own, but it's really a preference, right? But I'll go ahead and just give those to you on problems, so that way we're all on the same page, and also with the bins, right? So your idea is being able to create these Excel formulas, right? But this is where I disagree with Dr. Eric Gaze. I mean, he does an excellent job presenting this, but I think there's a much easier way to do the countif function than how he's telling you, right? So I'm going to delete this, and I'll go ahead and delete these and show you how I would do this, right? So I would set this table up the same way, but I would hit equals and then use the countif function, right? So you just type in countif and double click on that, right? So it's telling you it's going to count the number of cells within a range that meet a given condition, right? And then my range is going to be what I call data, right? And then the criteria is actually just what's here, right? So I can just hit G4 and hit enter, right? So now what it's doing is Excel is counting how many are less than 18, right? That's what the formula does. And now data, remember, that's going to be an absolute cell reference. It's not relative. It's not going to change as I pull things down. But G4 will, right? G4 will pull things down as I move this down. And I'm not going to want to move this function left and right, only up and down, right? The way the table's presented. But see, G4, I do want the row to change as I move this down, right? So that way it grabs whatever's to the left, right? So this Excel formula is exactly how I want it, right? So I'm just going to drag that down, and I get all those counts, right? So now what we're doing is trying to put things into bins, right? I want to know how many numbers are between 0 to 18, right? And the parenthesis beside the 18 here, beside the bin, that means we're not including that value, right? So all the way up to 18, but not including 18. And then you see, like here on the second row, there's a bracket beside 18 now. That means we're including it, right? That's interval notation, which you should have seen like in an algebra class, right? So this would be 18 to 22, not including 22, right? And then 22 to 26 doesn't include 26, and so forth, all the way down. So now what we want to do is calculate the frequency, right? So the frequency in the first bin is just going to be the values that are less than 18, right? That's gonna be numbers between 0 and 18. Excuse me. But when we look at values that are less than 22, right? What we have to do is we have to take how many values were less than 22, but then you need to subtract off the values that are less than 18. So we need to subtract off the cell H4, right? And again, the reason being is I want to know the numbers between 18 and 22. So we need to get rid of all the numbers less than 18. Because when you see less than 22, that counts all numbers less than 22, including the numbers less than 18. Right? So we don't want to count those numbers twice. So we need to subtract those. Right? We just want what's in between. Right? And that will be true all the way down, right? So now what I can do is I can just fill this down, and these should be the right counts, right? And to double check, if I highlight all of this, you'll notice at the bottom, one characteristic it'll tell you is the sum of the selected cells, along with the count and the average, right? So the sum is 98, which is how many data cells I have, right? So that is good, right? Oops. Let me get rid of this chart. So I think that chart was already there for you, right? But I'm going to show you how to make it, right? So in order to get the chart, what we want to do is highlight these two columns, bands and frequency, and then you're going to go to Insert, and then we're going to go to Bar Chart, and you can pick just this first one, right? Cluster column. Let me make this larger for you. Right? So a histogram, if you remember from the text, is a special bar chart, except the bars touch each other, right? So I need to get rid of the space in between the bars. So if I double click on the bars, I'll get excuse me, I'll get this option on the left. So what we need to do is reduce this gap width, right? So I might type in, like, I don't know, 5%, right? So if I do that and hit enter, notice now my gaps are very small, right? They're touching, right? Very close to touching. And then lastly, where it says frequency, I can go in here and edit this. So I could do like histogram of cat scores, right? So now I have the histogram, right, made. Right? So that will show you how to do those descriptives. All right, so it looks like we missed a few questions. So let's go ahead and fill this in. Right, so I'm just going to make a note. Let's see here. Oops. Oops. Pen isn't working quite right, so I'm gonna type in, well, on this, right? All right. So one thing I'm just gonna note is that see, this was not scores. Right, we let B4 to B101 be called data, right? That's what we call data. So I'll just put that there just for our reference, our notes, right? So you might want to write that in. So then to find the mean, right, we typed in equals and then average. And then open parenthesis, typed in data, and then close parenthesis, right? That calculated the average, right? So for median, right, what we typed in was the Excel function median, and then data inside, right? For mode, we typed in equals, mode, and then data. Right, for standard deviation, we typed in equals SD, open parenthesis, data, and then close parenthesis. Right? Or excuse me, it wasn't SD, it's STDEV. Right? That's SD is a command in a different program, right? But in Excel, it's STDEV, right, for standard deviation. Right, to find the max, we typed in equals max and then data inside, right? And then to find the minimum, we typed in equals min and then data inside. And then with range, right, we took equals, and then you had to take the max minus the min, right? So what we could do to make this more general is we could type in the max of data minus the minimum of data, right, if you wanted. Or what we did is we actually referenced the cells where we calculated the max and the min. So we typed in equals, let's see, that would be E8, right? Yeah, E8. So we typed in E8 minus E9, right? So we just referenced the exact cells we calculated those in, and that's perfectly fine too, right? So then to count, you would type in equals and then count, and then the range that you want to look at, right? We call it data, right? So then now what we're looking at, so for the histogram, we're looking, what is the output 45 telling us in H6, right? So what this is telling us, if you remember, is the following. So this is telling us there are 45 scores less than 26, right? So it's counting how many cells are less than 26. So how do you name a cell range scores, right? So what we did, remember, is we let me type in here. Right, so remember what we do is you highlight the cell range, click in the name box above the column heading A, where the cell range will be listed, right? Then you simply type in a new name and hit enter, right? And that will do it. Right, so highlight the cell range, click the name box above the column heading A, where the cell range will be listed, and then you just type in the new name and hit enter. Right, that's how you rename that. And then number 11 says the countif function has two arguments. What are they called in general? Right? So in general, the arguments or the inputs that we're putting into the countif function is the range of data that we want to look at and the criteria, right? Well, these are basically, you're saying this is the group that we want to look at, and then this is the criteria they have to meet in order to be counted, right? So that's how we would go through that. Then for number 12, it said what formula should be put in for H7, right? So what we put in, well, remember we did this a little differently in Eric Gay's. We brought down the formula from H4, right? So if you remember, in H4, this is what I put in, equals, oops, so I'll say we put in equals count if data, comma, and then what, G4 into cell H4, and then filled down, right? So I'll just put that. So that's what we would have done to pull that down, right? So the formula in cell H7 is equals, and then count if, and then it would have been data G7, right? Then close parenthesis, right? So that's the formula that you could have just typed in, but I was just making note for what we did, right? So now number 13 says, why is there 14 cells in H5 but only 11 cells in J5, right? And remember, what we had to do is we had to get rid of the overlap, right? So let me see if my pen is working now, hopefully. Not sure why it's not wanting to work right. Alright, so I'll try to draw this with my mouse. So if we have a number line, right? Let's say it starts at 0. And here is 18. And then here is 22. Right? So when we find the values from 0 to 18, we're counting all the numbers between these two boxes, right? But then when we count all numbers less than 22, then you are counting all of these values, right? So we want to get rid of this overlap here, right? We want to get rid of that. So that's why we subtract those two cells, right? We take H5 minus H4 to get rid of that overlap, because we're only concerned about the numbers in between 18 and 22, right here, right? That's what we're concerned about. So that's why there are 14 cells in H5 but only 11 in J5, right? We had to get rid of that overlap. So then next, it says what formula is in J6? Right, so J6 should be equals, so H6 minus H5, right? So again, to get the count for J6, which is 31, so numbers 22 to 26, we have to take all the numbers less than 26 and then get rid of all the ones smaller than 24. So their difference are the numbers that are in between, right? Just as I demonstrated above, right? So now it's saying, asking us to finish the histogram, but I already did that in Excel, so you can, you know, go off the histogram and fill in these bars. But that's all I have for this worksheet, right? That ends that worksheet. But now what I would like to do is talk a little bit about distributions, right? So in Canvas, I also posted this file, distribution of box plots. So let me pull this up. Right? So here are common distributions. So when we draw a histogram, we also get like this overall shape from the histogram, and this can tell us information about our data, right? And we're going to talk more about distributions. So on this first row, we'll notice first of all in this column I'm going to label what the distribution is, and then in this column this is what the histogram you know, could look like, right? It's an example of what the histogram could look like, and then to the right of to the right of the histogram column is the distribution shape. So in general, that's just showing what the distribution shape will look like, right? So this first row, this distribution, this describes what we call a symmetric distribution, right? So if you remember back when you took like some geometry classes in high school, junior high, you should have learned about symmetry, right? So things are symmetry when we can draw a line and they're like mirror image of each other, right? So a symmetric distribution doesn't have to be exactly that extreme where it looks, exactly 100% the same on both sides if we draw a line in the middle. But overall, we want, for a symmetric distribution, we want like the highest part in the middle and in the left and right seem to be pretty well even, right? So notice like this histogram given, it's not a perfectly symmetrical, but we call that symmetrical in statistics, right? And then here the distribution shape, in general, this is about what it looks like, right? So if I draw a line across this, over across the histogram, we get about this shape, right? So you can kind of see how they would like overlap. So then the next row, this type of distribution would be called right skewed, right? And I know it seems backwards than what you would think, right? But right skewed is where our data is kind of like pushed to the left, right? The bigger values are on the left side, but we call it the opposite of that, if you will. We call it right skewed, right? So here's a histogram about what that would look like, and then here is the distribution shape, right? So if we go down to the next row, this is about the opposite, right? We actually call this left skewed, right? So this is the opposite of right skewed. And again, it seems like a bulk of our data is like pushed to the right, right? But we call this left skewed, right? And then the next one, this is what we call bimodal. So a bimodal distribution is where you have two of these like hills, or we call them mounds in statistics, right? And something to notice is that you can have the mounds can be the same height, or they can be different heights, right? So I have two different distribution shapes showing both cases, right? And typically when we have a bimodal distribution, what that is an indicator of is that we probably have two groups in the same data set, right? So for example, if I collected heights of all Marion Tech students and I made a histogram of that, it would most likely have a bimodal shape, right? Because one mound would typically be like for females and one mound would be like for males, right? So our groups are naturally going to split like in these two different mounds when you have more than one like distinct group in one big data set, right? So bimodal again typically means more than one grouping, right? So when that happens, you would want to break it out into separate groups if possible, right? And then the last distribution I have here, this is where your distribution is pretty flat, right? So you can notice with the distribution shape, it's pretty flat, right? So in other words, almost every value is the same, right? But notice in the histogram, not every value has to be the same, but this is still the same distribution, right? So again, in practice, it's not going to be perfect, right? But we call this a uniform distribution, right? And again, that's where almost all of our values have like the same frequency, right? All right, so then next we have box plots. So box plots is is an example where our data is split into different categories. Let's see. See, actually, I think I'm going to redo this part of the video for box plots, and I will upload this very soon. Hopefully, I can get my pen to start working, so that way I can draw on this, and this can be more helpful. All right. So that's all I have for now. Let me know if you have questions. Bye.